In this question we are given that the list T consists of 30 positive decimals. So let's write down the information as we read the question. So list T has 30 positive decimals and none of them are integers. The sum of these 30 decimals is equal to S. We also have an estimated sum. So initially the value of S that was given to us is actually the actual sum of these decimals, and the estimated sum is equal to E, and it is calculated as follows. We are given that each decimal in T whose 10th digit is even is rounded up to the nearest integer, and each decimal in T whose 10th digit is odd is rounded down to the nearest integer. Now let's break this statement into parts and try and understand what it actually means. Now considering the first part where it is given that each decimal in T whose 10th digit is even. Now let's take a number such as 1.2. So here we can see that the 10th digit is even. Now what happens after this? It is rounded up to the nearest integer. That means we will write this as 2. Similarly, if I have another number which is 1.8, I will write this as 2, or 3.6, I will write this as 4. So this is what the first part of the statement means. And we are given that each decimal in T whose 10th digit is odd. Now let's take a number in which the 10th digit is odd. Suppose we take 5.3. Then here it will be rounded down to the nearest integer. That means we will write this as 5. If we take another example such as 8.17. Now here the 10th digit is 1 which is odd. So we will have to round down to the nearest integer. That means we will write this as 8. Now if you may have noticed, we can see that for even integers what is basically happening is that we take the integer part of the decimal and add 1, so that we get the actual value of how the sum is being estimated. And in case of odd, we are actually adding just 0 so that the number remains the same. So keeping this in mind, let's move on to step 2 and understand the methodology. We are also given that 1/3 of the decimals in T have a 10th digit that is even. That means out of 30, 1/3 of 30 is equal to 10. That means 10 of these decimals have 10th digit which is even. Then the other 20 will have the 10th digit will be odd. We have to find out which of the following is a possible value of E minus S. Now to solve this question, let's write down 1.2 as 1 plus 0.2 and 1.8 as 1 plus 0.8. Now this is changing into 1 plus 1 and this is changing into 1 plus 1. So basically this will give us the actual sum and this will give us the estimated sum. Similarly, 5.3 can be written as 5 plus 0.3 which will give us the actual sum, and 5 plus 0 which will give us the estimated sum. Now keeping this in mind, we move on to step 3 and calculate the difference of E minus S. Now E will be equal to, if the number is 1.2, then E will be equal to 1 plus 1, and if the number is 5.3, E will be equal to 5 plus 0. Similarly, like this, we will have 30 and the actual sum will be equal to, so the first number we considered was 1.2, so the actual sum will be equal to 1 plus 0.2. plus 5 plus 0.3 and so on till 30 decimals. Now, when we find out the difference of E minus S, we know that the integer part will all get subtracted and we will have 10 ones, that is 10 minus the decimal part. Now, to find out the possible value, what can be the least value of the decimal? Now, this can be equal to 10 minus 10 times 0.2 and the least value of a decimal in odd, which will be 20 times 0.1. Now we are taking 10 and 20, 10 numbers whose 10th digit is even and 20 numbers whose 10th digit is odd. This will give us 10 minus 2 plus 2. This is equal to 10 minus 4 or 6. So 6 is a possible answer. Similarly, when we take the maximum value, that is 10 minus 10 times 0.8 plus 20 times 0.9, the maximum of the odd number, we get 10 minus 8 minus 18. Now this is equal to 10 minus 26, which is equal to minus 16. So there are two possible values of E minus S, which is the option 1 and option 2, and hence the correct answer is option B.